Okay, y'all, this unit is going to be all about right triangles, and so we're going to start with something simple today that y'all already know about. There's just going to be certain things that I point out that are a little bit trickier that you have to make sure that you understand. But otherwise, today is pretty straightforward. We actually start with section 8.2 of this unit, and then we'll go back and hit 8.1 next time. So yeah, just our normal Pythagorean theorem. We know we use this when you're trying to find that third side of a right triangle. Okay, and so it's just important to know the parts, obviously, of this right triangle. So these two parts of the triangle, we're going to call those the legs. Okay, and then that longer side, we know that that is our hypotenuse. Sorry, my pen's not working very well. Okay, so that's our hypotenuse, and you just have to make sure that if you have a certain set of values that that hypotenuse is the longest side. Okay, so here's our Pythagorean theorem. A squared plus b squared equals c squared. Pretty straightforward. It gets a little more complicated when you end up having x's and radicals, but pretty much just pretty straightforward. So this says in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So that is where the Pythagorean theorem comes from. All right, so we're just going to do these examples together. So number one, you can see that they give us, but it's going to be the x side that's going to be our hypotenuse. And so it doesn't matter, obviously, which one of these are a or b, but that x needs to be the hypotenuse. And so I'm going to have 3 squared plus 7 squared equals x squared. At that point, you could have probably just said that's 9 plus 49, but for the video purposes, I'm going to write out all the steps. So it'd be 9 plus 49 equals x squared, okay, which is going to be 58 equals x squared, and to remove that squared, we need to take the square root. Okay, and then remember the trick in your calculator if you're trying to figure out what numbers go into that, because we're looking for perfect squares. So if you go to your y equals, you can do 58 divided by x, pull up your table, and then look in your table and see if there are any perfect squares in 58. There are not, actually. So the answer here is just square root of 58. Okay, number 2 is probably the one with the most amount of work. So I'm actually going to clear and erase this stuff over here so I have more room. So if you need that back, just rewind it. Okay, and so over here I have x, which is my hypotenuse. Remember, your hypotenuse is going to be across from your right angle. Sometimes when triangles get all flipped around, we lose sight of that. Okay, so I'm going to have 4 squared. Whoops, I just wrote 14. 4 squared plus, now here's where you have to be careful. That's going to be x minus 2 squared is going to equal x squared. Okay, so we're going to simplify this. So this will be 16 plus, now when you're doing x minus 2, this is a part that a lot of us would do wrong. This is x minus 2 times x minus 2. Okay, whatever your way of working this is, great. I use the process of foiling if you just want to double distribute, however you do it. So that's going to be 16 plus x times x is x squared. X times negative 2 is minus 2x. The inside is minus 2x. And then negative 2 times negative 2 is 4 equals x squared. And I'm just going to keep simplifying this. So I can see I have a 16 and a 4. I'm going to start with my x squared. So I have x squared minus 4x. 16 and 4 is 20 equals x squared. Okay. Right now I see I have an x squared on both sides. So those are actually going to cancel out. So I'm going to need to either move the 4x over or move the 20 over. So I'm just going to subtract 20. So I have negative 4x equals negative 20. Divide by negative 4 So after all of that work, x is going to be 5. Okay, you will definitely see something like that in the future. Okay, number 3, here I'm trying to find x. Okay, so what I'm going to do is I'm going to draw this vertical line that goes down, and you want to look at that and say, okay, what is the length of that? Okay, well that would be 8 because it matches up with the side across from it. And then down at the bottom it says the whole thing is 11. Well, I know from here to here, I know that piece is 5, which means this piece over here is 6. And so what we're now looking at is this triangle over here. So I'm going to do Pythagorean theorem to figure out the length of the hypotenuse here. So that'd be 8 squared. I'm just going to go ahead and say that's 64 plus 6 squared is 36 equals x squared. So that's 100 equals x squared. Take the square root, and so x is 10. Okay, number 4. Okay, here it's saying that this side is x, which means all of the sides are x, right? Because they all have the tick marks. And so now I can just do Pythagorean theorem. I guess maybe next class actually, you will learn how to do this, and by not doing the Pythagorean theorem, you'll figure out a different way. But for now, we're just going to do Pythagorean theorem. So we'll have x squared plus x squared equals, now here's where you have to be very careful. 5 square root of 2 needs to go in parentheses and square it. If you don't put parentheses around that, what you're going to end up doing is you're going to square the square root of 2, but you're not going to square the 5. So you got to do them both. All right, so now we have 1x squared plus 1x squared, so that's 2x squareds equals. Now I'm going to write this next part out because you got to make sure you know how to do this without a calculator. Okay, because there's going to be a part of this test that you get the calculator on and a part where you don't. Okay, so I still have 2x squared. But if I do 5 square root of 2 times 5 square root of 2, I'm going to do outside times outside, so that's 25. Square root of 2 times square root of 2 is 2. Any square root times itself is going to be the number underneath. So square root of 2 times square root of 2 is 2. Square root of 100 times square root of 100 is 100. Now the calculator would tell you that, but you may not get the calculator on this part, so you want to make sure that you know how to do that. So that's 2x squared equals 50. And now I'm just going to keep solving. So I'm going to divide by 2. So x squared equals 25. Divide by, take the square root. So x is 5. Okay, I'm going to erase some of that so I have room over here. All right, so this next one, the perimeter of the square is 60. Notice it is saying the perimeter of the square, okay, is 60, and it wants us to solve for D. Okay, well, if the perimeter is 60 and all the sides are the same, 60 divided by 4, all these sides would be 15. And I'm trying to find D. Okay, so I'm going to have 15 squared, which is 225, plus 15 squared, which is 225, is going to equal x squared. Okay, so 225 plus 225 is 450 equals x squared. Okay, and then now I need to find perfect squares in 450. Well, I know 225 goes into it. So 225 times 2. The square root of 225 is 15. And so my answer here is 15 square root of 2. And that's the length of the hypotenuse. Okay, this next one says if A is 3, so I'm going to go ahead and write all of these on here as I'm reading it. So A is 3, B is 12, and C is 15, determine the value of X. Okay, so what I am first going to do is is, oh, and I forgot that this is also a b down here, so that's 12. Okay, so first, well, there's a couple different places I can start. I am going to go ahead and figure out what this entire side is here. And so to do that, that would be 3 squared, which is 9 plus x squared equals 12 squared, which is 144. Okay, subtract 9. So x squared equals 135. And then I'm going to take the square root of that. And there is a perfect square that goes into that. It's 9 times 15. The square root of 9 is 3, so I'm going to bring that out. And so that would equal 3 square root of 15. Okay, so that's that entire side. 3 square root of 15. Okay, but we're just trying to find x, which means now I need to figure out what this piece is down here so I can subtract it from it. And so I'm going to call that, I'll just call it y. So I'll have y squared plus 12 squared, which is 144, equals 15 squared, which is 225. Subtract 144. So you have y squared, well, my handwriting's really bad on here. 225 minus 144 is 81. Take the square root of that, and so y is 9. So now if I just wanted to find x, I need to take the red piece, which is 3 square root 15. And I need to take out the purple piece, which is 9. And so if I just want x, that is going to be my answer. I cannot combine those because they're not like terms, and so that's just where it stays. All right, so this next thing is talking about find the length of the hypotenuse in the right triangle formed by these equations. And so you just need to make sure you know how to graph these lines. I think that we do. So I'm going to graph this first equation in red. So I'm going to start at 1, and I'm going to go up 3 over 1. It's kind of hard for me to do on here. 2 over 1. Okay, and you're going to get that line on there. Probably straighter than mine is. Actually, I think I can make this cleaner. Oh, that's a little nicer at least. Okay, and then x equals 0, so think Buck's Hoy here. So that's going to be a vertical line at 0. So I'm going to have this line here. And then the last line would be y equals 4, so that's 1, 2, 3, 4. And that's going to be horizontal. And so what we have is this little itty-bitty triangle here. Okay, and so what I always do is I go ahead and I just redraw it out here so that I can see something a little nicer. And you just need to be able to count. So mine you can't see very well, but this across the top is just going to be 1 unit. And then this going along this side is 3 units if you count it. And then what we're trying to find is the hypotenuse. So it would be 1 squared, which is 1, plus 3 squared, which is 9, equals x squared. So 10 equals x squared. Take the square root. And so x would equal square root of 10. You'll have, I don't know, a couple of those, but they're not that hard. Okay, so we're just going to do another one of these. And actually, yeah, we're going to do it. So I'm going to subtract 3x here. So y equals negative 3x plus 4. So I'm going to go ahead and graph that. I'm going to start at 4 and go down 3 over 1. Just make sure that your slope is negative here. Okay, so I have that line. All right, and then I have y equals negative 2. So I'm going to go to my y-axis and put a point there. This will be a horizontal line. Okay, and then x equals -1, so this is going to be vertical, going through -1 on the x-axis. Okay, so what we have here is this triangle here. So I'm just going to draw that out here so I have a nicer picture. And if you count, you'd have 3 across. And just make sure you count when you're going vertically, that you count all the way up to those points where they meet, and it's a distance of 9. And so now whenever you do Pythagorean theorem here, you'd have 9 squared, which is 81, plus 3 squared is 9, equals x squared. Add those up. So 90 equals x squared. Take the square root. You got to look and see, are there any perfect squares in 90? And there are. 9 times 10. So we'll bring a 3 out from the 9, and I'm left with square root of 10. Okay, this next slide is talking about Pythagorean triples. There's only like certain Pythagorean triples that you really need to know, and really just so you can be more efficient with your time. And it's these 4 that you see going along the top on your notes. Okay, so these are certain triples that you'll see, like 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. And if you don't have it memorized, fine, you know, you can just do Pythagorean theorem, but it does save you some time if you do. So what you'll see on the column underneath the 3, 4, 5 is if I multiplied 3, 4, and 5 by 2, I would have a 6, 8, 10. If I multiplied 3, 4, 5 times 3, I would have a 9, 12, 15. So you kind of get the gist there. If I had a 5, 12, 13 triangle, and I multiplied all those by 2, it would be 10, 24, 26. And so if you just know these, it saves you some time. So number 1 says the legs of a right triangle are 3 and 4. What is the length of the hypotenuse? So that one's pretty straightforward, right? Here's the length of our legs, 3 and 4, which means the hypotenuse would be 5. Okay, the next one, the legs of a right triangle are 27 and 36. Okay, so 27 and 36. What is the length of the hypotenuse? Okay, and so I would look at this and say, okay, 27 and 36. What would that be based off of? And you don't see it in the table. And so you'd have to say, okay, well, what number goes into both of those? Okay, well, 9 goes into both of those. All right, so maybe that this is a 3, 4, 5 triangle. Okay, and if that's the case, if 3 was multiplied by 9 to get 27, 4 was multiplied by 9 to get 36, then 5 would have to be multiplied by to get to 45. Again, if you don't know that, that's fine. You can just do Pythagorean theorem. Number 3, the leg and the hypotenuse of a right triangle are 24, 26, respectively. What is the length of the other leg? So you can see that right here in the table. And it's 10, 24, 26. The only thing I would advise you of here is just be careful, because if you had, I'm just going to erase this so I can have room to draw a picture. But if I had a triangle and I had like 3 here and 4 here, you need to be really careful that you do not think that this other leg is 5. Okay, because remember, your hypotenuse is the one that needs to be the longest side. So this would not be right if this would not be 5. So just be careful of something like that. Okay, so now we're going to talk about, and this will be quick, the converse of the Pythagorean theorem. So the converse of the Pythagorean theorem is saying, like, if you know certain things, then you can classify the triangles. So last semester we did obviously a lot about triangles, but we talked about how to even decide if numbers could create a triangle. And the way that we did that is we said the 2 smaller sides, so the 2 small had to add up to be greater than the 3rd side. Okay, and that was just to decide, could it create a triangle? Okay, well, what this converse is saying is, okay, Well, if the two smaller sides equal the third side squared, sorry, let me backtrack. If it does create a triangle, then we're going to classify it. And so here's how you're going to classify it. You're going to plug it into the Pythagorean theorem. And so if a squared plus b squared equals c squared, then the triangle is going to be a right triangle. Okay, that makes sense. The next one is if a squared plus b squared is greater than c squared. Okay, so if a squared plus b squared is greater than c squared, that means that it is going to be acute, which you have to be really careful of because your first thought is it's going to be obtuse, and it's not. It's acute. Okay, if you look at this example down here, okay, you can kind of justify some of these things. So a squared plus b squared, if it's less than c squared, then it's going to be obtuse. So it's kind of backwards, right? You think greater than should be obtuse and greater than is actually acute. So can triangles be formed here? If so, are they right, acute, or obtuse? So I'm first going to check, is 6 plus 8 greater than 12? Yes. Okay. If so, then I'm going to plug it in and check. So 6 squared is 36, plus 8 squared is 64, and 12 squared is 144. So is 36 plus 64 greater than, less than, or equal to 144? Well, that's 100. And 100 is less than 144. Less than means this is going to be obtuse. Okay, the second one. So first you have to check, is 2 plus 21 greater than 25? And no, it's not. So this is not a triangle. You can't even classify it because it's not one. Okay, the third one is 14 plus 48 bigger than 50. Yes. So now I'm going to just plug it into the Pythagorean theorem, and I'm going to check this. And so 14 squared is 196, plus 48 squared is 2,304, and 50 squared is 2,500. And guess what? When you add those two numbers together, they do equal 2,500. So because these are equal, this would be right. Number 4 is, first you have to check, sorry, that bell's loud. First you have to check, is 9 plus 10 greater than 12? And it is. And so I'm going to plug this in. So 9 squared is 81, plus 10 squared is 100. So you make sure you put these in the right order. And I don't know if that's equal. I shouldn't have put an equal sign. And then 12 squared is 144. And so if I add these up, 181 is greater than 144. So this is acute. Okay, and then the last one, we're just bringing in square roots. So you do need to check 3 square root of 34 and make sure that that is at the longest side, the shortest side. You just need to check. So when I type that in, it's like 17.49. Okay, so is 9 plus 15 bigger than that? Yes. Okay, now I'm going to square these. So 9 squared is 81, plus 15 squared is 225. And here's where you got to be careful. If you are going to type this in the calculator, which again, you may not have calculator on this part for the test, then you've got to put that in parentheses. Because what you're doing is 3 times 3, which is 9, and square root of 34 times square root of 34 is 34. And 9 times 34 is 306. So, and if you do 81 plus 225, you get 306. So 306 equals 306, which means that this is a right triangle.